So I would like to talk about hardwood in construction. Hardwood refers to the timber of the broadleaf species. Timber construction is growing rapidly since something like 10 to 15 years. When you look at an architectural magazine these days, you find a lot of examples of modern timber buildings due to the discussions about climate change and emissions. Timber structures are gaining a lot of momentum. And I would like to talk about the role of hardwood or broadleaf species in timber construction today. When you look at Germany, Germany has a lot of forests. Germany, 1/3 of the German area is covered by forests. And if you look into these forests, you will find the tree species distribution, which has about 44% of broadleaf species and 56% of coniferous species. So roughly 44% is hardwood. And as you heard today, the forests are changing. The next generation will have much more broadleaf species. This will be up to 73%. And if you look in timber construction, into the timber construction business, there is a totally different picture. In timber construction, hardwood hardly plays a role. The amount is something like 1 to 2% only. Timber structures are dominated by softwoods today. And the Thünen Institute in Hamburg has summed it up as follows. They have summed up that they have summed up the increasing occurrence of hardwood and the limited utilization for products are an ongoing problem of forest industry today. If you ask a forester in Germany, what's your main problem? He would possibly say it's difficulties finding customers for our broadleaf species, for species like European beech, for instance. If we look a bit more deeper into the hardwood species, into the broadleaf species, you will find that beech, European beech, is the most common broadleaf species in Germany. Beech amounts for about 67% of hardwood in Germany, and that's very similar in the neighboring countries, in countries like Austria, Switzerland, or France. In Germany, we have a European beech stock of roughly 548 million cubic meters. We have an annual growth of 18.3 million cubic meters, and we have an annual harvesting volume of 10.9 million cubic meters. And if you compare the last two figures, you see that there is a huge difference. 18.3 million cubic meters of growth compared to 10.9 million cubic meters of harvesting volume. That will be very much in favor of this person, Karl from Karlowitz, a German forester, who formulated the principles of sustainability, that you are not allowed to harvest more than is growing in the same period of time. If you look at European beech in Germany, there's a huge difference between growth and harvesting. So we have a lot of reserve in European beech, a lot of reserve in terms of increased harvesting that is possible without violating the principles of sustainability. And this leads to the fact that beech is one of the timber species with the largest reserve from sustainably managed forests. If you want to look for a specific wood species where you can increase usage easily from sustainably managed forests, that would be European beech. So why isn't European beech used much more for timber structures? Well, it's pretty difficult to make a beam from a tree. If you look at the beech logs here in the picture, most of the logs are not very straight. They have a lot of large knots, and to transform these logs into a product you can build with, into a glulam beam, for instance, that is a lot of hard work because you need to cut it into small pieces, into small boards. You need to cut out the knots. The drying of beech is pretty difficult. And that means glulam, traditional glulam made of beech boards, is a product that you can buy today that's pretty easy to manufacture, but it's pretty expensive at the same time. European beech glulam, if you purchase it today, it will cost around 2,000 euros per cubic meter. If you look at the same product made from spruce, from European spruce, that will cost 500 euros per cubic meter. And if you look at that huge difference, then you know why why glulam from European beech is a niche product, because it's 4 times more expensive. Our company asked the question 5 years ago, can it be done more efficient? Can it be done more efficient to make from a tree a beam? And we said, yes, that's possible with new technology, and when you use veneers rather than boards in form of laminated veneer lumber. We developed, nobody had ever done that before with a hardwood in the world, so we had to develop a new process, and finally in 2014 we started our production after investing something like 120 million euros into a production facility. I have prepared a short film of the production facility that shows quite quickly how we produce laminated veneer lumber from beech. I hope the film gets through the weak internet line. I hope it's working and visible for you. The first step is that the logs are put into a hot water for 48 hours. We have just seen that. The logs are debarked, cut to standard sizes, and then are peeled. That's a peeled veneer which we produce here. It's a very quick and efficient way of producing veneer from a log. It's a rotary peeled veneer, and you get all what is left is a 10 centimeter core of that beech log, and the rest is turned into one long slice of veneer, which is 3.5 millimeters thick. That's a peeling machine. The veneer is cut into standard sizes, and these standard sized veneers are then pulled into a veneer dryer. Since the veneers are thin, the drying is quite quick and easy. The veneers are dried within 15 minutes down to a moisture content of 4%. After that, the veneers are scanned. They are checked for knots and the discolorations and sorted into different grades. After that, resin is applied, a phenolic resin. You can see that now.
3 minutes
and
left.
After that, in the next step, the veneers are laid into an endless strand of laminated veneer lumber. That's a two-step process. The first step, books are formed, and then those books are married together to form a continuous endless strand of laminated veneer lumber. The endless strand runs through a large press. It's a continuous press, high pressure of something like 3 Newton per square millimeter, and heat are applied. The board is heated to 10 degrees, and under these conditions, laminated veneer lumber board is manufactured. In the next step, These boards are processed further to Baubuche GL75 beams. The boards are sliced into lamellas, which you can see on the left side. These lamellas, on these lamellas, a second time, glue is applied, and then those are stapled into beams. They are driven into a press, and there is a secondary gluing process to form large-scale beams. With this process, we produce 4 different products. You can see from the left the Baubuche Q. That's a board. That's a basic product. There are 2 types. Q does have some cross-ply veneers. With board S, all veneers are directed into the same direction. If you put those lamellas on top of each other with a secondary gluing process, you can produce large-scale beams. And there is a 4th product, which is Baubuche Panel. It is a product with all the veneers upright standing. It's just for visible applications like stair steps. What's special about this product? First of all, it's much more efficient. The large-scale beam is costing around 700 euros per cubic meter. If you compare the traditional way of manufacturing beech or hardwood into glulam, costed around 2,000, so it's much more efficient, much cheaper, that product. The second thing, Baubuche GL75 is very strong. Very strong means the strength characteristics compared to traditional glulam made from spruce, a typical material for building, are roughly speaking 3 times higher. We have 3 times higher strength, which means we can build much slimmer structures, we can do wider spans, we can build higher buildings, and so on. And that leads to the next topic. What is laminated veneer lumber used for? It's either used for tall wooden buildings because of its high strength. It is used for wide span roof structures, and it is used for building with visible wood structures because beech has a very good surface characteristics. You know it from furniture. So those are the 3 typical applications. Have we done projects since 2015? Yes, we have done many projects. You can find them on our websites. I'll just give 3 examples. One example is a 10-story office building in Zug in Switzerland, 10 stories with all posts made from European beech. The size of the post is as slim as if they would have been done with reinforced concrete. The compressive strength, 60 Newton per square millimeter, is very similar to concrete. So the size of the elements does not need to be larger than concrete. And you, in theory, you can build as high as you can build with concrete. The second project I want to show is a production hall which we built in Germany, in Waldenau, for the company SWG. It's a screw manufacturer. This production hall does have a free span of up to 42 million European beech. It's a 5-story building, and if you with the high loads in the ground floor, all have been done from European beech. Thank you very much for your attention, and please ask questions.
Thank you very much, Mr. Hassan, for this very interesting view. I think there is some hope for future hardwood production for forest owners. So I have a very short question. Is it also applicable, this approach, for other broadleaf tree species than beech? For instance, oak, which might be a future tree species in climate change. Is it also applicable for oak?
Yes, it would work equally well from a technical side for other species like oak. It has not been done yet because getting all the technical applications, all the technical data is connected to the species. If we were to use oak, we would need to do that again for oak. That would take something like 2 years and cost a few €100,000. So with that burden, it would be possible at any time.
Okay, thank you. And then there is a last question by Constantin Launeux from University of Brussels. He asked, do you see any future automation in non-regular size tree transformation thanks to, for example, to image recognition or any other form of artificial intelligence?
I didn't really, could you repeat, please?
Do you see any future automation in non-regular sized tree transformation thanks to, for example, image recognition or any other form of artificial intelligence?
It's difficult to answer. The boundaries of what we can use for laminated veneer lumber are quite wide. We can use trees as thin as 25 centimeter in diameter and as large as 1 meter. And also other characteristics like knots or curved beams do work well in this production process. So we already have a very wide range of what we can use, but I don't know if that answers the question completely.